There we go. Okay, thank you and welcome to FCA International's September safety call. We made updates, little administrative piece here. We did make updates to the COVID model exposure control plan for the US. This includes some more information on vaccines, protecting the unvaccinated employees, and a few more things. Darlene Schonder will begin sending this information out to anyone who has already received a plan. And if you haven't, or you don't already have a plan in place, make sure you visit our resources page at finishingcontractors.org to request one. We do have we are working on finalizing our updates for our Canadian version as well, just trying to iron out a few more details on that at this point. And then with these COVID updates, some of them can be a little confusing. They seem a little counterintuitive at times. So if you have any questions on the information, please do not hesitate to reach out at safety helpline at finishingcontractors.org or 844-414-SAFE for all your questions to be answered by our safety professionals. All right, and with that, we are very excited about today's presentation. We are welcoming back Rich Martin of Optimum Safety to speak on fire safety. Rich gave this presentation, I think, a few years ago now. He's a former firefighter, retiring at the rank of captain, and now works with Optimum as a safety professional. So Rich, first, thank you for your service as a firefighter, and welcome back.
Well, thank you for having me. I'm glad that the presentation I did, I looked at my records. I want to say it was back in 2018. So I'm glad it left an impression, and I'm looking forward to doing it again. There are some few updates in there, but fire is fire, safety is safety, and it doesn't change all that much. So if you've seen it before, it'll be a good refresher. If not, I hope there'll be some really good information for you to take back with you. So first thing we're going to do, and please, I hope we're not too formal on this. If there's any issues with the video, please let me know. But I'm going to start out with this video here just to show fire behavior and how quickly a fire can build up. All right, so you should be seeing a small fire in a small waste can in a room. All right, I see Bob nodding his head, so we're good.
Looks good.
So this was a simulation done under test circumstances. They lit a fire in a wastebasket in a simulated family room / living room. You'll note the clock in the lower right corner. So we're 1 minute in. Typical school of thought is that fire and an incipient fire, which is what we're seeing here, doubles in size about every 60 seconds. We don't have enough smoke yet to set off the smoke detectors. Now we're going to start generating some smoke. If the smoke detector is not in the room with the fire, and let's say there's a header over a doorway, that may trap smoke in that room until it becomes low enough to travel through that doorway to a smoke detector in another room. They used to say smoke detectors in the hallway outside bedrooms were sufficient, but now they're saying smoke detectors should be in every bedroom. You could see the smoke itself burning along the ceiling before this started. In the upper right corner, you can see the smoke itself burning. 2.5 minutes in. you'll note that there's fire where there was no direct fire before, right? That's because the room temperature had gotten so hot that the ignitables in the room just started up and fire. Flashover is where everything in the room gets hot enough to just ignite, even though there's no direct contact with flame. So at what, about 2.5 minutes in, the room was fully involved. Firefighters now are just putting out the fire. So purpose of that video is to show you how quickly fire can build from a little carelessly discarded cigarette into a trash can, into full involvement of a small family room in 2.5 minutes. Can your fire extinguisher put that fire out? No, you saw the 2 firefighters with the fire hose dumping probably about 100 gallons a minute into that room. And that will have a significant impact on that room. But a simple 5-gallon bucket full of water or a simple standard 20-pound fire extinguisher, if you even have those on your construction site, would not be sufficient for that fire. So let's look at how fire works. Fire has 3 components. That's why we call it the fire triangle. First component to the fire triangle is going to be the fuel itself. This can be ordinary combustibles. Take a look in your trash can right now, papers and wrappers and whatever else is in there. Can also be liquids like gasoline, gases like your acetylene tank on your construction site. Maybe you don't work with it, but it's there on the construction site. Can be natural like wood, can be man-made like plastics. So there's your fuel. Oxygen is a major component of fire, 20.9% of the atmosphere. It's always present. There's very little you can do to control the oxygen content in a large area. And then finally, heat. If you combine these three components in sufficient quantity, you will have a fire. Heat can be from an open flame like you saw in that trash can, sparks related to cutting and welding and other hot work, heating coils inside equipment, overheating or coming in contact with something that's flammable, electrical arc, or just high temperature. Remember in the video, we commented on some of the items that were bursting into flame, even though there was no direct flame contact. So there's your fuels. Flammables, liquids, and gases are the most common. Matter of fact, that's pretty much what you will find. And you can see in here typical fuels that you will find on any construction site. If we look here, now this is indoors. You guys work in indoor construction sites. You can see a number of things that could contribute to a fire here. Paper goods, careless storage, an oxygen tank back there, just junk. If we want to reduce the likelihood of a fire, you remove the fuel, you don't have a fire. In this case here, simple, proper storage of materials and maintenance of general housekeeping can significantly reduce the likelihood of a fire and limit fire spread. Oxygen is not flammable, but it does promote burning. Many people think that oxygen will explode if you get it exposed to fire. Oxygen does not burn, but under pressure, it can cause ignition of flammables, especially hydrocarbons, which is why when you have compressed gas cylinders and you screw a regulator onto your oxygen bottle, you want to make sure that your hands are clean and they don't have any oils or residues on them. Just the act of screwing on that hydrocarbon contaminated seal onto the oxygen cylinder, when that cylinder is opened up, that can cause a flash explosion, and people have been burnt because of that. And it's not the oxygen exploding, it's that hydrocarbon fuel that is suddenly bursting into flame. There's a little video on how oxygen makes flame burn. Note the little stick of wood, all right? He let the fire go out, just a tiny little flame. If oxygen were going to explode, this jar would explode, but it doesn't. You can see how it does make that flame burn really, really well when it's exposed to pure oxygen. All right, he blows it out, just a tiny little ember, and it bursts into flame again to the point that it's jetting out of the jar. So that's how oxygen affects fire. It promotes combustion If you want to reduce your fire risk, you reduce the oxygen content. 20.9 is what God gave you in the atmosphere for oxygen. If you have more than 20.9% oxygen, you have a leak somewhere. You're introducing oxygen either from a compressed gas cylinder, or you may be creating oxygen by a chemical reaction that causes components to break down and release oxygen into the air. In construction, you're more likely to use up oxygen in hot work and in breathing in confined spaces than you are to create oxygen. But if there's extra oxygen in there, it's usually because of damaged components. You can see here a welding cart. If you look at the hoses on the right, you can see some cracks in the outer sheathing of the gas and the oxygen hoses. That's going to lead to premature failure of the hoses and leakage of potentially hazardous chemicals into the atmosphere. So routinely and regularly inspect your equipment, especially as it relates to ignition sources and oxygen. So heat is the next component in the fire triangle. Open flame, obviously, a torch, a propane heater, wand that's being used to heat up components in cold weather, a torpedo heater, most common sources of heat, but also embers and smoldering materials resulting from hot work that you may have done or carelessly discarded burning materials. You don't need me to read the list, but you can see there are a number of potential sources for ignition in a construction site, even static electricity. I don't know if you guys heard about the chemical plant that blew up in Waukegan probably 2 years ago now in May. I think it was in 2019. They think what happened was hydrogen off-gassed as a result of a chemical process. And the simple act of opening up the garage door, the overhead garage door, to let out the gases created a spark in the motor somewhere that ignited the hydrogen and blew the building apart. So when we talk about static electricity, it could be electricity in an electrical component like a motor, or something as simple as shuffling across the carpet and touching the doorknob could create enough of a spark to ignite a hazardous atmosphere in the right mixture. So when we're looking for ignition sources, take a look even at, this is a plant here, it's not construction, but you can have electrical damaged electrical components in construction as well. I can go onto any construction site on any given day and probably find a minimum of 2 or 3 extension cords that have damage and exposed conductors, plugs pulling away from the wire, tools that need repair. And we know it, we see it all the time. So look for those kinds of things. Regular inspections of the facility to make sure that fuel is under control, regular inspections of the equipment to make sure that there's no ignition sources will also reduce the likelihood of a fire. When you're conducting hot work, all flammables must be removed from the area, and you must have a fire extinguisher immediately available. In the picture on the left, you have a gentleman who's cutting ductile iron pipe using a powered saw. And you can see the sparks shooting off there. So they have the sheet of plywood to prevent the sparks from going out into traffic and also to deflect them down to the ground. On the right, you see a gentleman cutting holes in some trench box spreaders for excavation work. You don't see it because I didn't capture it in the picture, but just in the lower right corner of that picture, just outside that corner is the bumper of the truck, and he has a fire extinguisher right there ready for use. If you are performing hot work, creating sparks or flames or slag or embers, a fire extinguisher should be immediately accessible so that if something does ignite, it gets put out right away. Fought a house fire once where a bunch of welders were welding an overhead I-beam above the overhead garage door. So they're building a house and they're putting an I-beam over where the garage door is going to be. They welded it in place and some molten slag got between the face brick and the wood frame of the house. And 2 hours later, we were getting called out for the building under construction on fire. Simple matter of vigilance, somebody watching what was going on there, seeing the stuff falling between the brick and the wood, and pouring 5 gallons of water down after it would have been sufficient to keep that fire from going down. So fire extinguishers, a means of extinguishment, and fire watch is important when you're doing hot work. So here we have the fire triangle: fuel, oxygen, heat. If you just take one of them away, your fire will go out. All right. If they're all there, your fire can be there. All right. So now we understand how fire works. So now we're going to look at fire prevention. And we're going to try and relate it to the construction site. This here is a picture of an electrical room. You will have electrical rooms on construction sites, especially buildings under construction. There should be nothing ignitable in that electrical room. As a matter of fact, there should be nothing stored within 36 inches of the front of the electrical equipment. So if you're looking for a place to lock up your tools or lock up your plans or lock up something that's flammable, putting them in the electrical room is not a good idea. So how does this relate to the construction site? Electric is often still in a state of installation. It's often not buttoned up. You may have open electrical boxes. You don't know if the conductors inside are energized or not. If there's open electric or electrical activity going on, we want to make sure that nothing flammable is being stored in front of those service panels that are being installed or electrical equipment that's running across the floor. So keep an eye out for that. Here we have an office built into the electrical room. You can't see it in this picture, but the humorous thing is half of these signs say, don't put anything in front of these panels, don't have anything in this electrical room, danger high voltage, and the maintenance guy established his office in here. And this room, all 4 walls of this room are covered with control panels and service panels and motor control centers and all of that. So stay away from the electrical equipment. Just revisit this picture once again to reinforce proper storage of materials, get rid of the trash. I see a 55-gallon drum over there in the upper left quadrant laying on its side. What's in it? A flammable liquid, a slippery liquid. Either one, it's not good. If it's empty, it should be stored outside. If it's full, it can be stored inside, depending on what the contents are, but they should be stored in a manner that prevents the buildup of gases or the release of gases and liquids. That oxygen cylinder back there should be secured to a wall or a rigid structure to prevent it from falling. You'll see the valve covers on it, which is good. If the cylinder does fall over, the valve cover will protect that valve from getting knocked off and then releasing oxygen into the room or creating a torpedo situation. But overall, this is not an acceptable situation. You can go down the list and you can have trip and fall hazards. You can have exposure hazards to chemicals. You can have laceration hazards, just on, just in this single picture. So general housekeeping should be maintained throughout the workday and then cleaned up regularly. Already talked about this one. So what is the biggest cause? Actually, let me just double check here. Yeah, hot work. Okay, so what's the biggest cause of fires and workplace accidents? Usually human behavior. All right, we're taking a shortcut. We're in a hurry. It's close to the end of the workday. The pressure's on. The general contractor wants this job done yesterday. Whatever it is, distractions, complacency, general fatigue because we stayed up too late the night before. We're just working too hard, too much overtime, whatever it is. Simple things like careless smoking. Human behavior, human error, or people factors are among the biggest causes of safety incidents and fires. So we'll take a look at fire extinguishers here. The SDS sheet for the chemicals that you have in your workplace will tell you a number of things you need to know to be safe. Section 5 on the SDS sheet is your firefighting measures. So if you were to have a chemical that you're not completely familiar with, you can look in Section 5 to determine whether or not it's Section 2 to determine whether or not it's flammable. And if it is, Section 5 on what the best measures are to fight those fires or to prevent a fire from happening. And you can also see accidental release could lead to a fire. improper handling and storage of the material could lead to a fire. Physical and chemical properties will be listed in section 9. What's the flash point? The flash point is the temperature at which the chemical will ignite. Gasoline, for example, will ignite at something like 300 degrees below zero. Diesel is a little warmer. You know, it might ignite at 40 degrees below zero under pressure. So it's not as flammable as gasoline. Upper and lower explosive limits, vapor pressure. Vapor pressure is the likelihood that the flammable liquid will turn into a vapor, a gas, which is what is burning. And vapor density refers to whether or not the gas likes to rise to the ceiling or settle on the floor. So those are all factors that I guess for most construction guys might be a point of interest. But when you are thinking of a propane leak, where's the propane going to settle? Propane's heavier than air, so it's going to settle on the floor. So just because you open up the room doesn't necessarily mean that it's going to evaporate off into the sky. It may settle on the floor, and then somebody tosses a lit cigarette down on the floor right into a collected propane leak and set something off there. So there's 5 types of fires. Class A is ordinary combustibles, your campfire, your trash fire, your dumpster fire. Flammable liquids, gasoline, kerosene, lighter fluid. Energized electrical fires are generally Class A fires that have an electrical component to them. In other words, the electricity is still live. So here we're talking about a piece of equipment with the motor on fire. Would be a Class C fire. If you were able to shut down the electric, it would just turn into an ordinary combustible fire or a Class A fire. Class D is for flammable metals, Class K for cooking. You guys aren't going to run into those that much. But you do need to know what kind of fire extinguisher you need. So fortunately, they have ABC fire extinguishers, which are, you know, they relate back to ABC. You can use them to fight ordinary combustibles, flammable liquids, and energized electrical fires. So here's a chart that the Department of Labor, OSHA, has provided, also from NFPA, that shows you what type of fire extinguisher you need. If you look at Class A fires, you can see that a CO2 fire extinguisher is not the best fire extinguisher for an ordinary combustible fire. Neither is a sodium or a potassium bicarb fire extinguisher, but a multi-purpose ABC fire extinguisher will work great. Note that all the way on the right, under multi-purpose ABC, you have stored pressure and you have cartridge operated. You don't see cartridge operated much anymore. That stored pressure is the type that is most commonly seen. You can see it has a range of 5 feet to 20 feet. So you have to get fairly close to the fire. What's 20 feet? It's about 6 steps away from the fire, right? So you can't stand back outside the fire room and start squirting the powder in there. You need to get the fire powder, the extinguishing agent, onto the fire. So here's your ABC fire extinguisher. And if we take a look at it, they'll have labels there, like that silver label on the right. We'll flip it to its side and we'll look at this fire extinguisher and note that it says it is a 4A 60BC fire extinguisher. All right, so we know it's ABC. What does this mean? Each A, 4A, is equivalent to 1 1/4 gallons of water. So this fire extinguisher is equivalent to about a 5-gallon bucket of water. I don't know about you, but when I want to put out a fire with a 5-gallon bucket of water, you can't do much with a big fire. So is it a good idea to have multiple fire extinguishers in position, you know, or on the location? Sure. Multiple people trained to use them and can use them properly. That's something to certainly to consider. Each B is equivalent to square footage. So 60B is 60 square feet of a flammable liquids fire, which comes out to about a pool of gasoline no bigger than, say, 7 by 7 or 8 by 8. 8 by 8 is 64 square feet. If you have a bigger puddle of a flammable liquid, that's a problem. Now, you can have a 2 by 2 flammable liquid fire in a bucket 6 inches deep. The size of your fire is only 2 by 2, because the only thing that's going to burn is the gases coming off the surface of the liquid. So you can have a gasoline fire, toss a match into it, or a 1 gallon bucket of gasoline, say a metal bucket, toss a match into it. The only gasoline that's going to burn is that which is on top of that liquid in that bucket. It'll burn down to the bottom. The bucket being metal probably won't melt right away, but it's not like you're going to get this big conflagration. You're going to have a hot fire, but it's not going to be as big as if it were spread out on the floor on, let's say, a 6 by 6 area. C just means it can be used on an energized electrical equipment fire. As I said before, shut off the electricity and it becomes a normal combustible fuels fire. The reason it's C is that if you were to shoot an energized electrical component with this fire extinguisher, the electricity would not jump to the individual particles of the extinguishing agent and come back to you like water would, for example. If you were to shoot an electrical fire with water, it's entirely possible that electricity could travel up that water and give you a good jolt. So what size extinguisher do I need? This is a common question in construction. The standard says you have to have at least a 2A fire extinguisher. So that's the equivalent of 2.5 gallons of water, right? For every 3,000 square feet of the protected building area. So if you have a 5-story building and each floor is 3,000 square feet, you need at least 5 fire extinguishers. The travel distance from any point of the protected area, so any point on that floor to the nearest fire extinguisher, shall not exceed 100 feet. Actually, it's better to do every 75 feet. But if you have to travel more than 100 feet to get to that fire extinguisher, then another fire extinguisher should be in place. Best location for fire extinguishers should be at the exits. The reason is you have an opportunity to leave the room by going to the exit. You can grab that fire extinguisher and then you can advance towards the fire, keeping the exit at your back, as opposed to going into the room to get the fire extinguisher and the fire builds between you and the exit and now you're trapped. So that's why it's always best to have a fire extinguisher at each exit and one within 100 feet, every 100 feet. That fire extinguisher, the second fire extinguisher, should also be visible from the first. If not directly visible because of obstructions and partitions, a sign up above that will say fire extinguishers right here, sign is also very useful. In lieu of fire extinguishers, the code does allow for another means of fire extinguishment. They mention 55-gallon drums of water with 2 fire pails, so you can travel back and forth between the fire and the 55-gallon reservoir of firefighting water, or having a 1/2-inch garden type hose, no longer than 100 feet, that you can use as a continual stream of water to put on the fire. A fire extinguisher rated not less than 10B. So remember 10B is 10 square feet, right? So a fire about 3 foot by 3 foot. Fire extinguisher rated not less than 10B shall be provided within 50 feet anytime you have more than 5 gallons of flammable or combustible liquids or flammable gas used on the job site. How big is your fuel can on the construction site? Between 2.5 and 5 gallons usually, right? How big is an acetylene tank? More than 5 gallons. The tank itself probably weighs between 150 and 200 pounds. So if you start seeing flammable liquids, 2 5-gallon cans of gasoline to run powered saws or powered equipment, we need to start having bigger and more fire extinguishers. Fire extinguishers need to be inspected monthly. OSHA refers to NFPA 101, and NFPA 101 states that fire extinguishers must be inspected regularly at intervals not to exceed 30 days. So that's where that monthly requirement comes in. If you look at most fire extinguishers, there'll be a service tag on it that shows the last time it received a proper inspection and certification. If you flip that tag over, there'll often be a grid on the back that says, January, and then a spot for initials, February, and a spot for initials. So we recommend the first Monday of every month, look at all your safety equipment, look at all your emergency equipment, your fall protection harnesses, your fire extinguishers, your first aid kits, your exits. Is everything the way it should be, so that if people have to evacuate the building quickly, they can. If people have to grab a fire extinguisher to fight a fire, it's where we expect it to be, and it's in good working condition. If we have to grab a first aid kit in order to patch somebody up, that's ready to go. And the exits, are they all open and unlocked and available to be used during operational hours? Or did someone forget to unchain or unsecure a door and now people can't get out? So the first Monday of every month, go through all of those things and make sure they're in good shape. When we're looking at the fire extinguishers for inspections, we want to check the overall condition of the extinguisher. Is it rusting and corroded? Has it picked up new dents, especially around the base, where the base section is welded into the body? You drop those a few times on the ground, you can start getting leaks in the welds, and you may not notice it. It's not going to come rushing out, but the next time you want to look at your fire extinguisher, the gauge is down to 0 because there's a hairline leak somewhere in a weld. So check the overall condition of the fire extinguisher. Make sure the pin is in place. You can see in the upper right corner, there's a pin that goes through the squeeze handle. That needs to be secured in place so that when someone picks up the fire extinguisher to carry it somewhere, to move it, they don't accidentally squeeze the two handles together and cause a discharge of the agent. When it's secured in place, it needs to be secured in place with a breakaway zip tie so that it can be easily removed just by yanking on the pin. If you have to search for a tool like a knife or a side cutter or some other tool in order to release that pin, it's going to cause a delay in fighting the fire. And you saw how quickly that fire can build. You also want to make sure that pressure gauge is within the normal range. You see the little green range there. If it's past the green range, that's unusual. It could mean that the cylinder is overcharged. It could also mean there's a problem with the gauge itself or with the pressure sensor inside the cylinder. So it could actually be discharged. And because the gauge is defective, it would look like it's overcharged. And if it's discharged, remember, a 2A fire extinguisher is equivalent to 2.5 gallons of water. If you've already used half of that fire extinguisher on some small fire somewhere else, the next time you need that fire extinguisher for a bigger fire, it may only have the equivalent of a gallon of water in it. So anytime they get used, they need to be recharged, re-inspected, and put back in position. Look at the certification date. In this case here, you see it was checked in 2019. And if you look at the little punch hole there on the third slot from the right, you see it was checked in March of 2019. The certification is good for 12 months. So this one here would need to be re-inspected in March of 2020. Or if we're looking at this today, we would say this thing is over a year out of date. You can see also that there's a little punch hole right above maintenance. The guy was a little sloppy. So when he did this inspection, he did some maintenance checks on this extinguisher, and it was done in March of 2019. If he was expecting a new, fresh out of the box extinguisher, he would have punched new. And if he needed to recharge it because it was used, he would have checked. This one was re-inspected and certified because it had been used. If that tag is damaged, illegible, or missing, that fire extinguisher needs to be pulled from service and replaced, recertified, and replaced with one that is good to go. So there we go, a little bit tighter picture, March. We want to do an annual service inspection and document that inspection on the back of the tag. As I mentioned before, you can see there on the back, there are little slots that allow you to initial when the thing was inspected last. How to use the fire extinguisher. If you remember the acronym PASS, P-A-S-S, you pull the pin, you aim the nozzle at the base of the fire, not at the flames, but at the fuel itself, so at the base of the fire. Squeeze the handle, and then sweep the spray from left to right, advancing forward until the fire has been extinguished. You want to have a deliberate pattern of starting where the fire is closest to you and then advance forward, pushing that fire away from you until it's out. This can be difficult to do with a flammable liquids fire. It takes training and it takes practice. Flammable solids are a little bit easier. So that's the presentation for fire behavior, fire presentation, and fire extinguishers. Any questions? I'd be happy to address them.
Thanks, Rich. Any questions for Rich? If so, either put it in the chat or unmute yourself and ask.
Hey, Rich, is there a recommended fire extinguisher for job sites that are using those 100-pound propane tanks?
So those are tricky because propane burns hot. And what it does is it also heats up the cylinder. In reality, the only situation for a propane fire as a result of a still leaking cylinder is lots of water. Right, I'm going to move my camera over here so I'm looking at you as I talk. So you need lots of water in order to cool down that cylinder while at the same time trying to put the gas out, the fire out. Remember that if you put the fire out, you will still have escaping gas. All right, so that can be a problem. If you have a active gas leak, let's say you hit a gas line in the building and it lights on fire. As long as there are no exposures, in other words, nothing else is going to light on fire, often it's good to just let that fire burn and just protect other things from starting to burn. Otherwise, what ends up happening is you have that gas releasing into an enclosed space, creating a enclosed hazardous atmosphere that could reignite, this time with explosive results. So for a propane fire, a cylinder that's actually burning, water is still the best bet.
For storage, Rich, obviously here in the Midwest, it gets pretty cold here. Is there a storage? Can it be too cold to store it in like a garage at times, or is there a certain temperature you need to be storing it in?
So storing what?
The extinguishers, I'm sorry.
The extinguishers. So when compressed gases get colder, they reduce in volume. So in cold, think of this, a gasoline can. If you had a plastic gasoline can and you left it out in the middle of winter, you've left it outside after topping off your snowblower, what would that can look like when you went out in the morning? Usually the sides will have compressed in. It's a metal can, they might even have collapsed. So the same thing is going on inside a compressed gas cylinder, which is what a fire extinguisher is. So you will have a reduction in pressure. So storing them outside in the cold is not best because you'll have less life in the fire extinguisher. So instead of it being a 2A, it might only be equivalent to 1.5A because there's just not enough pressure. That pressure will come back as the can heats up again. But if we can store the fire extinguishers in 50, 60 degree temperatures or better, that would be perfect. Think about the fire extinguisher on your foreman's utility truck though, or just left outside in the cab of whatever equipment is out there. Do know that in cold weather, your fire extinguisher is going to have less capability than if it was stored at room temperature.
Sure.
I guess the follow-up to that is, what's the top side temperature? And is there an issue if it's 90 degrees or 95 degrees or even 100 degrees in some of our warmer areas of the country?
Not typically, because what is the gas that's in there? The gas that's inside the fire extinguisher is air. All right, so it's not like it's going to have an expansion ratio of 1,500 or 1,600 to 1 like propane might. So if the temperature is cool enough for you to handle, it's cool enough for the fire extinguisher to handle. If it becomes so hot that you can't handle it anymore, well, you might stress the fire extinguisher a little bit. but you'll feel the results of the heat long before that fire extinguisher will. You do want to keep it away from direct sources of heat. And if you can keep it out of direct sunlight, that of course is better. But storing it outside where it gets exposed to direct sunlight for a few hours, it's going to make the extinguisher hot to touch, but it's not going to affect its ability to fight a fire.
I've got one last one. And it's, so are we saying that there is a definitive, is or is not a definitive life on the extinguishers, or as long as they're, you know, the container's in good condition and it says it's, you know, properly charged or whatever, it still continues to be good?
So that's a good question. It depends on the fire extinguisher. Most portable fire extinguishers are rechargeable, most portable fire extinguishers used in construction are rechargeable and reserviceable. Some of the smaller ones, like the kind you might get at Ace Hardware or Home Depot, and they're to put under your sink in the kitchen, or maybe the ones that are in your trucks or your equipment. If they are not serviceable, they have a life of about 12 years. And that should be stamped somewhere on the body of the fire extinguisher. If they are serviceable, every 12 years, they will, when the guy comes out to recertify your fire extinguisher, he'll say this one needs to be hydro tested, and he will take it, and it will go through a process where the entire fire extinguisher is taken apart, every component examined, the cylinder will be filled with water and pressurized to check for expansion to make sure the body of the fire extinguisher doesn't expand too much. And once it passes hydro testing, it's certified again for another 12 years. So it depends on the fire extinguisher.
Is there a proper way to dispose of fire extinguishers then, if you want to get rid of them? I mean, you don't just toss them in the trash? Is there a safe way to handle
They're not a hazardous material. My recommendation is always take them to the local fire department and drop them off there. A lot of times they can use them for training. Maybe you can't use it anymore because it's out of date, but maybe they can use it for your local citizens. I forget what they're called, but like the auxiliary fire department, where the citizens can sometimes help out in emergencies, and you can show them how to use a fire extinguisher, or, you know, the Boy Scout troop can come to the fire department for some training and they can use them for that. Probably the best solution, if you're just going to throw them out, is discharge them safely, you know, making sure that you're pointing it downwind. Discharge them safely and throw them out, or just give them to the fire department and let them handle it.
Sure. You can do your own training before you.
Right.
Yeah. All right. That's great stuff. Before we sign off, any questions for Rich? If not, that's okay.
One last question, Rich. Is there a specific training that's required with the fire extinguisher?
So anyone authorized to use fire extinguishers needs to be trained on how to use a fire extinguisher. For best results, it should be live fire training. In other words, we're going to actually put out fires with the fire extinguisher, but there is no requirement that the training be live fire training. They do need to be trained on how to use it. They do need to have some hands-on, review of the fire department, so they can actually hold on to it and see what they're looking at, practice the techniques of pull the pin, aim the nozzle, squeeze the handle, sweep side to side. But they do need to be trained, and they do need to be trained annually. Often a toolbox talk review and a tailboard, here's the fire extinguisher, take a look at it, remember it, you'll need it later. Often that is sufficient to meet the requirement. It's probably not sufficient in order to be predictable in putting out fires. That only comes with practice.
Now, is that type of training only really done like with a fire company? Or can that training be obtained other places?
Fire departments don't typically do it. That would depend on your local fire department. Usually that kind of training is done by a contractor or by a qualified and competent person on site who knows how to do it. There's no certification requirement. There's no, in order for you to be a fire extinguisher trainer, you have to hold this certification. You just need to have skill and experience, understanding of what the limitations of the fire extinguisher are and how to use it.
Thank you.
All right. Okay, before we do sign off, I just want to just a reminder that in FCA's safety manual, it does include a fire prevention program in there. So if anybody is looking for something like that, please reach out for that. And with that, Rich, thank you so much for the presentation today. With your experience and knowledge on this, it really makes it a great presentation. So can't thank you enough for that.
Thank you.
Thanks everyone for joining, and we'll be having our October one. We'll probably focus on COVID-19 updates. So we'll look forward to that. Yeah, thank you everybody for your time for today. Take care.
Thanks, Rich. Take care.